Everyone, since we had a few people who seem to struggle or it seemed to be a little bit more of a challenging problem, right? There's a lot to do with this one. I figured that I would sit down and do a solution for this for you and walk you through an approach for doing this, right? Just to give you an example of how it could have went and maybe clear up any questions you might have had, and anybody who got stuck on certain parts, how you could have gone about solving it, right? So let's go ahead and get to it. So first thing I do, if I'm going to solve this problem, a student, I'm going to solve this problem. First thing I'm going to do is I'm going to read the thing very, very, very carefully, right? The goals. And of course, you could also go back and watch the intro videos that I do for the modules where I walk you through the assignment requirements, right? But anyway, so you're going to use vectors here. I know I'm writing functions. I know I'm going to be processing lists of values stored in a vector. It's going to be modular, and I'm going to be doing some sorting here, right? Because this module was all about arrays and vectors and sorting and searching and all that sort of stuff. So that's kind of in my mind. So here's the requirements here. So I'm going to write a program that reads numbers from a text file into a vector. And then the program is going to display the numbers sorted in ascending order as well as the average of the numbers and the highest number. To do this, I'm going to have to implement the following functions. So I read these functions, very, very carefully, right? And I make sure that I get a good overview of what it is that I'm supposed to be doing. And if there's anything that I'm not exactly sure about the requirements, I email my professor, or I go back and reread that section of the text, etc. Maybe go back and watch one of the lecture videos or what have you, right? I noticed that there's a hierarchy chart here that's going to tell me exactly what order to call everything. I noticed that I have a scoring guide here that's going to tell me what's worth the most. So I definitely want to make sure that I do a good job on my load function, on my sort function. I got a sample run here. That's going to show me what I need my output to look like. Take a look at the hints, and hints here, plan your program before you code it. So my plan, it's already been kind of planned out for me because I know I'm going to have a main function. I'm going to have all these different functions, right? So I know I'm going to do that, and then I have to think through each individual function. I'm going to work on one function at a time and work through those. Okay, write and test each function one at a time. It's a good idea. Remember to close your file. There was multiple people who didn't do a close statement in the function. I even put it right there, right? And it says here, you may assume the file contains at least one number in it. One student, I think, put some code in to their functions, testing to see if the vector was empty. A couple of things about that. One, the get size function rejects any values that are 0 or less, so this was never going to be a possibility. You may assume that the file contains at least one number in it. So I'm good there, okay. There's no user input in this program, so I know that I'm not going to be asking the user for anything. It's more efficient to use a constant vector reference parameter than pass by value. Okay, you get access to the data and the argument vector without having to call it. Okay, fine. Here's an example of making a constant vector reference parameter. Okay, so this is something to keep in mind. And you take a look at that and go back and read some of these function descriptions. It says here, accepts a vector as its only argument by reference, calculates returns, does not interact with the user in any way. So no see in or see out statements, uses the algorithm for chapter 7 to calculate the average. So we just go back to chapter 7, look for that. Reference should be a constant reference. Right down here, it talks about constant references. So I know this is what a constant reference now looks like, right? So this is an example of one. All right, so I need to name my source code file a certain thing. Okay, fine. So what I'm going to do is after reading this, I know that my vector is going to get populated by this load function, okay? So find highest, find average, sort, print, they all depend on that load function. Okay, so the load function is going to be the most important one in this entire assignment. So if anything goes wrong with my load function, then my find highest, all the rest of the functions are going to be, problematic. I mean, worthless. I'm not going to know if there's something wrong with them if the load is broken. So what I'm going to do is I'm going to work on these other ones first. Okay. And then once I know those are working, because these are going to be easier, I think. So once I know that these are working, then I'll start working on my load function. And if anything goes wrong with my load function, I'll know it's the load function, okay, and not these other guys. So let's start doing that. So what I'm going to do is I'm going to look at find highest, and I'm going to do that. So it accepts a vector as its only argument by reference, okay? So it's going to find and return the biggest value stored in the vector using an appropriate algorithm. Does not interact with the user in any way. The reference should be a constant reference. Okay, so let's go and work with some vectors. So I'm going to need to bound include a vector so I can gain access to vectors. I don't think there was any requirement here to use prototypes. Okay. I don't see anything here about that. So I'm gonna use vectors anyway, or excuse me, I'm gonna use prototypes anyway, just because I feel like it and I like prototypes. So find highest, that's the name of it. So I got that. So I'm gonna say find highest. Okay. And then function finds and returns the biggest value stored in the vector. Okay, now what type of numbers should I use here? Let's see here. It says write a program that reads the numbers from a text file into a vector. So what are numbers? Integers are numbers, but floating point numbers are numbers too. So I'm going to be working with doubles or floats here. Doesn't say which one I have to use, right? Just so long as I can work with numbers. So I can use a 4-byte float or I can use an 8-point double. My professor didn't tell me which one explicitly, just that I have to work with numbers. But I'm just going to decide, just because I feel like I'm going to work with doubles here. So the highest value in the vector is going to be a double. I'm working with doubles, so my return type is going to be double. Okay, and so I have to pass to this function, let's see here, a vector as its only argument by reference. So it's the parameter list is going to have one item in it, and it's going to be a vector. Now, the vector is going to be a vector of what? A vector of doubles, because of the fact that the numbers are coming from a text file, and we already decided that the numbers, or we talked about all the numbers are going to be floating point numbers. So floating point numbers means double, okay? Now it says then I have to pass the argument by reference, okay, right there. And it says here that the reference should be constant. So I'm going to go put const here. All right. And that is my prototype. You don't have to put parameter names in the prototype. So I got my return type, I got my name, I got my parameter list. So now I'm going to just copy this, and I'm going to paste it down here. And I'm going to have to name my parameter. So I'll name it V. And so I'm doing find highest here. So the find highest algorithm that we saw from chapter 7 was for arrays, but who cares? We can do it with vectors too. So I'm going to start off by creating a variable, which I'll call high. And it's going to be double because I'm working with doubles. I'm working with floating point numbers, right? And I'm going to initialize that with the first element of the vector. Okay, this in the algorithm for arrays in chapter 7, it initialized it with the first element of the array. So I'm going to do that here with the vector. And then I need to have a loop, and I'm just following what's in chapter 7. So I'm going to have a counter variable there, and I'm going to initialize it to 1 because I'm beginning by assuming that the first element is the highest. I don't know that, but I'm beginning with that assumption. So I don't need to compare the first element against itself or the contents of the first element against itself. So I'm just going to move on to the second element as the text does, just to save an extra step. And okay, so long as I is less than the size of the vector, right? So here, the difference between vectors and arrays is that a vector is intelligent. You can ask it how big it is. You can't do that with arrays, and it's because of that fact that we don't have to have a second parameter here. We're just going to ask the vector, all right? And so then we'll go ahead and increment our I. Now we're going to do our test. If the current element that's being examined is bigger than what's in high, Okay, then what we'll do is we'll update high with the current element of the vector. So this is just like the algorithm that we saw in chapter 7 for arrays. Same thing. We're just using vectors now. And I don't want those curly braces there, so I'm going to take them out. All right, so once I'm done, high is going to contain the highest value in the vector, and so we'll return that. Now I'm going to, before I do anything else, before I write another function, I'm going to test this function. So I'm going to make a dummy vector, right, and of doubles. And I'll just call this v as well. And I'll initialize it with just some random numbers, just some numbers off the top of my head. 1.1, 2.2, 9.6, 3.1. Okay. And then I'm going to call the function find highest. I'm going to pass it the vector. And then I'll just send what it returns straight to cout, right? I just want to test find highest. That's all I'm doing. So let's go ahead and run this thing. And we'll see what we get in the output. Okay, it should be 9.6. And do you see that 9.6? I think my browser window's in the way. Yeah, there's the 9.6, right? So success, right? That's the biggest number in the vector. So I'm good. So I'm confident with find highest. We can check find highest off of the list. Okay, so let's take a look at the next function. Find average, and also notice that too, I double checked my find highest description here. It doesn't interact with the user in any way. Mine doesn't. There's no C or cout statements in find highest. Awesome. So let's move on to find average. Okay, and find average is kind of similar to find highest. At least the prototype is. So double find average, right? Because the average is going to be a floating point number, most likely. So we're going to return a double. We need to pass just a vector, right? Just like before. You know, if we look at the requirements, vector is its only argument by reference. I have that reference there. Okay, it's going to be constant. I've got the const there. Okay, and I got the name right. So let's go ahead and make this function now. Okay, doing that. Okay, so we're going to need a variable, an accumulator, that is going to, because we have to find the sum, right? And then we have to divide the sum of all the elements of the vector by the size of the vector. So we're going to need an accumulator. Right? Don't forget to initialize your accumulator. A couple people did do that, and I docked you half a point for it. All right, so then what we have to do is we have to add up all the values in the vector. So we just need a loop that goes through the entire vector, right? So we could use a for loop just like this, or you could use that that range-based for loop that we learned about. And I like that, so I'm going to use that. Okay, and then we're just going to do sum plus equals the value. And then we're going to return the sum divided by the size of the vector. Okay, so we'll go ahead and we'll double check that. So I'll go call it find average. I will pass it the vector, right? My dummy vector, and then I'll just send that to cout as well. And I'll get rid of this because I already tested it. So let's run it. And then you'll be able to see there's the average 4.86. How can I double check that? How can I test that to make sure that's the right value? Bust out a calculator, right? Use Windows calculator or use the calculator on your phone, whatever. Just double check it to make sure that the number's right. And you're going to find that the number's right. So I won't make you watch me bust out Windows calculator. But anyway, so I know that my find average is correct. So now let's go look at the next function. I got sort. Okay, so this is going to accept a vector as its only argument by reference. So I know what I need to name it. So sort. It's going to accept a vector by reference. Now notice here, it says use either bubble sort or selection sort as covered in chapter 8. The easiest thing to do here would have been just to copy and paste the bubble sort. I think it was in program 824, But there's a sample program in there that has a bubble sort function, a function named bubble sort. You could have just taken that code, modified it for vectors, copied and pasted it into your program, modified it for vectors, and made sure that you included some swap code, because some of you just, you did copy it, but you called a swap function without defining a swap function, or you included algorithm. Okay, we can't use algorithm, the algorithm header file, because we haven't covered that yet in the class. Remember, that's an explicit requirement, and you have to define function that you're going to use, right? So you had to include some actual swap code for doing your swapping. So that's what I would do, right? I would know that I can't do this, right? Because we haven't covered that header file. So that's against the rules. So I can't do that. And I can't just call a function swap. I can't just call a function without defining it. So I'm going to have to either define my own swap function or just have the logic for that code in the sort function itself. Either way was acceptable. This function does not return anything. It says right here, does not return anything. So that tells me it's a void function. Okay. So now I'm going to write this function. Okay. So let's see here. Why are you complaining? You should not be complaining. Oh, that's why I didn't put my closing angle bracket. Okay. So I'm going to take this and I'm going to write my sort function. Now there's a couple of different ways. I mean, you could have done selection sort, fine, and you could have copied the code from the text for that too. Bubble sort, fine. The implementations of the text, totally fine. But some of you noticed that in the labs, that the implementation was slightly different, or was different than what was in the textbook, right? And if you were one of those people and you decided to use that implementation, fine, right? I mean, it is, I went ahead and let you do that because we did cover that in the course. Okay, so that was fine. All right, so now let's take a look at this. So the implementation from the textbook had you use nested for loops, right? So you had something like this. It said something like for int I, or for int end element, or something like that, right? But you could name your variables whatever you want. So it was the length of the array minus 1, or in this case, since we're using vectors, the length of the vector minus 1. Okay, and so long as that max counter is greater than 0, we're going to keep going. And at the end of each iteration of the setter loop, we're going to decrement that counter. Okay, and then our inner loop started from the first element, okay, and then went up to that max value, right? That was defined in the outer loop. Okay, and then here's where you do your swapping, right? And you're checking for swapping. So if and I'm just, like I said, I'm just looking at the example straight from the textbook and copying that. So, and modifying it. So if what was it? If v of I is greater than v of I plus 1, right? Because I understand how the algorithm works, and we're going to be comparing adjacent pairs. Okay, so if they are out of order, then we have to swap them, right? So in the textbook, they had like a call that looked like this. Okay, swap I, swap v plus 1, right? Now here's the problem. You take a look at this and you can see, oops, this shouldn't say swap, that should say v. Okay, now take a look, and this should say I. Okay, I got errors everywhere. See, this is what kind of threw some people off as they looked at this and they were like, oh, there's no squiggles. It must be completely fine. No, it's not. Okay, the code is correct because the code is correct, not because Visual Studio or just because it compiles, right? Our textbook shows us, and this is the best practice, is that, when you have a function call, you have to have a function defined somewhere. So you had to, here if you were going to do this, then you needed to define the function, add an additional swap function would have been fine. And that would have been okay. Or you could have, and I accepted this too, you could have just added the 3 lines of code in here. Okay. Either of those would have been acceptable. Using the algorithm header file was not, because we've never covered the algorithm header file. And if you look in the textbook, that's what I would see. If I'm a student, I'm looking down, I'm reading that entire sample program, and that's what it shows. Some of you probably just read that sample program and then went on with your day, and you didn't scroll down a little bit further and see that there's an actual swap function that's defined. Right, and so that cost you some points. I can't remember. I think I knocked off like a point or something. It wasn't huge. I mean, if you missed that, I left you a little note. And you still got an A basically if that's all you did. But the swap code would look something like this. Let's see here. Double a little temp variable here, and we'll assign v of I, and then we'll overwrite that with v of I plus 1. Okay, and then we'll overwrite v of I plus 1, plus 1 with what was preserved in temp. Okay, so that's a perfectly fine, and we need to have our equals here. Okay, so that should be a perfectly fine implementation, but I don't know. We'll see if I made a mistake. We'll test it. Okay, so how are we going to test it? Well, let's go back up here and use our temporary, dummy vector, and we'll do sort v, and then I'll print out the contents of the vector. Right, so I could do double D v cout d, and then we'll just see. And if it doesn't work, or I don't understand why it doesn't work, I'll hand trace. Okay. And or go back to the sections of the textbook related to this algorithm, related to functions. Okay, but you can see that the values are actually all good. They're sorted. It's done. So now I know that my sort function works. Okay, fantastic. So we're just doing it one function at a time. So now I'm going to look at the print function here, and we're going to write that. And it is going to be named print. I know that. So print let's see here. It's going to accept a vector by reference in 2 numbers. Okay, so vector by reference in 2 numbers. We know that we're working with floating point numbers, and we're doing doubles, so we're going to go with that. Does not return anything, so that's a void function. Okay. And the reference should be constant. So we're going to go const. And you'll notice I don't have any names for my parameters here, right? I mean, you could put them in there. It's not wrong, but it's not required, and it's kind of weird to do that, I think. But if that's your preference, if that's your coding style, fine. Okay, so now we're going to go ahead and define this this print function. Okay, so I need to name my vector, and then I think that I have a high score and then an average, right? That's what's being passed here. So it says 2 numbers, the highest value and the average of the vector is its only arguments by value, right? So it's by value, so no ampersands for these guys. The function does not return anything. We got that. Prints the contents of the vector as well as the 2 numbers. Okay, so we'll do something like cout the contents of the vector, and then we'll say something like, I'll use that range-based for loop again. So for auto d v, and then we'll say, or I'll be consistent with what I did before, double. Okay, so then we'll say cout d, and I like putting spaces in between, move the cursor to the next line, and then cout the highest value is h, and the lowest value is, or the average. It wasn't the lowest, was it? It was average. Average value is A. Okay, so I got that using the buzz sort, selection sort, okay, print. Arguments by value, prints contents of vector. Yeah, I mean, so this function is pretty mindless. I mean, it's pretty. This should be easy. So to test this, I'll call my print function. I'll pass it the vector, and then I'll just pass a couple of dummy values, right? Because all I want to do is just make sure that it prints out what it's supposed to print, right? Doesn't need to do anything more than that. So let's hide this so you can actually see the output. So there's the contents of the vector, right? Not sort of, because look, I'm just testing. In my main, I didn't call anything but the print function. I just want to make sure this thing works. So it prints the contents of a vector plus its 2 arguments. So that looks good. Okay, so right. So at this point, my main. Let's take a look at my main. It creates and uses all necessary variables, calls all functions in logical order according to the hierarchy chart below. Does not interact with the user in any way. So there shouldn't be any cout or cin statements in main. And I need to call the functions in this order: load, find highest, find average, sort, and print, right? So I haven't written my load function yet, so I'll leave this here. I'm going to do that last, right? And then I need to call find highest. So we'll do double H equals find highest. But I already know find highest is going to work, right? So I'm not panicking. I mean, it's just, I don't even have to look at it again. So let me see. I'm going to find the average. So we'll say A for that. Find average. Pass it the vector. We got our sort function. Going to pass it the vector. I know all these functions work. And I got print, right? So I'm going to call that and pass the vector, the high score, and the average. Okay, so that should be my main, right? If I look at my main, it just says creates and uses all necessary variables, calls all functions, logical order. According to the hierarchy chart, does not interact with the user in any way. No cin statements. I'm calling everything in the correct order. Fine, let's test it. Let me get the browser out of the way so you can actually see the output. Right, so there's the contents of the vector in sorted order. Awesome. The highest value, 9.6, and then the average value, 4.86. So I'm looking at that and going, okay, the average. Yeah, the average, 4.86. We already established that works, so I'm not panicking about that whatsoever. Okay, so last thing, I got to do my load, right? I got to load. So the load function is going to read from a file, right? So I have to have a text file. You just create that with Notepad or with whatever. Just make one up. Make one on your own for testing purposes. So I did that, and I stuffed it with some numbers. And let's see here. There we go. So that is the project folder for my program, right? And so you'll see there's main.cpp, and right next to it is numbers.txt. And the Visual Studio, when you're developing this way, right, it looks for a file, a text file that you're going to open for reading by default in the same location as main.cpp, right? Now, depending on which IDE you use, it might bounce that around a bit. It might move it to other places. Fine, you would need to accommodate that based off of what IDE you're using. And God help you if you were using Xcode. But it's there and it's in good shape, right? So it's in the correct position. So now I'm ready to get started with my load function. Okay, and I can get rid of this this dummy list right here. Okay, so what I'm going to do with my load function is, I know that I'm going to need to name it load. Okay, let's go back and look at those requirements again. Okay. So load function, here we go. Accepts a vector as an argument by reference as well as a string by value. So I'm going to need 2 parameters here. A vector by reference, vector, double, and a string. All right. Now strings, we have to include string here, right? And tons of you keep forgetting to do that because the compiler lets you get away with not having done this. But I still marked you for a half point on it because program's correct because the code's correct, not just because it compiles. And so I left you a little note to go review section, I think it's 2.8. And in the text it says include, string and all the sample programs. And it even says you have to include the string header file. So you might be wondering, well, why does the compiler let me get away with it? And why does it matter? Whenever you use something that's not built in, that's not a primitive data type, say, like string is, then you have to pound include string, okay? Because not all compilers will let you get away with that. And the standard calls for you pound including string. Okay, and even if it works now, it might not work in the future because basically what's happening is that pound include string is being included by one of these other header files, but there's nothing to say that in the future, the Visual Studio's compiler or the IOStream header file may change. And so if it does that, then you'll have some legacy code somewhere that you wrote 5 years ago that just suddenly breaks in production and suddenly you're screwed, right? So the best practice is to include that string. That's why you lost points if you didn't, and that's why the textbook tells you to include it. So make sure that you include it. Okay, so let's take a look here. What else does it say here? Opens a file, uses a string argument. Okay, we're going to look at that in a second. Does not interact with the user in any way. Okay, so that's right. So there's not going to be any cin or cout statements in this function. Uses a default argument for the string parameter with the value numbers.txt. That was covered in chapter 6, I think 6.11. I could be misremembering the section, but it's in there. Most of you got it right. So I'm going to need to have my default argument right here. Okay. And then this function doesn't need to return anything, right? There's nothing, it doesn't call for returning anything, right? Reads the numbers, stores the numbers in the vector argument. Okay, so my return type should be void. I look at that. All right. And then it's time to write the function. Okay. So we're going to take our header file and we're going to copy it down here. And remember from that section covering default arguments, you don't need the default argument down here. So I'm going to take it out. Okay, that's not what the textbook did. Okay, I got to name my parameters. And I am going to be all good there. Now I go back here and it says, what was the file using the string argument? So that's what I need to do. I need ifstream, an ifstream variable. Okay, and I need to make sure that I pound include fstream because that is the header file for handling files. Okay, so we got ifstream fin. So remember how you work with files. I have to attempt to open the file. And so I'm going to do fin.open. And then I'm going to pass as an argument the string because that's what the requirement's called for, right? And then from here, I need to read all the numbers into the vector. And before I forget, let's remember to close our file when we're done with it. Now, some of you, what you did is you printed out, the error message. You did the if else thing, which normally is what you want to do, right? But partially, I tried to give you a little less work to do, and partially, I also wanted to try to catch you not following requirements, right? And I did catch some of you, a good number of you missed this. It says right here, the function does not interact with the user in any way. So that means that there's not going to be any output statements, right? Cout, there's no if else. So this implies that there's no, testing, whether it opened or not. Now, some of you just did the if fin.isOpen, and did that and then just left the cout statement off. If you did that, fine. I didn't knock any points off of it. But you didn't have to do this because there's no requirement to test it and no requirement to print out an error message if it failed to open. Okay. And if it did fail to open it wouldn't have mattered all that much because the rest of these functions, you'll see that it says v.size, right? The range-based for loop, goes off of the size of the vector, v.size. If the file never opens, okay, then the reading operations are going to fail and nothing's going to end up in the vector. So the vector is going to remain having a size of 0. And so if it has a size of 0, then none of these other loops are going to ever execute, right? So it's not going to be a problem. Okay, so you're not going to be accessing any invalid stuff. So open the file and then read all the numbers into the vector. So I'm going to need a little temporary buffer variable to do that. So we'll call that num. And so we'll use the while loop that we learned about in chapter 5 for reading all of the values from a file. So just something like this. And then the vector, we got to push it back. v.push back. We're going to put the number at the end of the vector. And that's literally it. And some of you did this. If you did this, this is okay too, right? This is, you can define an ifstream object variable and open it at the same time. Some of you did that. That's totally fine. And as a matter of fact, it's probably a little sexier to do it that way. A little bit more elegant because you have one fewer line of code. And close the file here. Now you'll notice that this is not constant. If you make a reference constant, that means that you can't change the argument, right? But we need to be able to change the argument because we're stuffing all these numbers into the vector argument. So that's why this isn't constant. I think there was one student, he was like, I couldn't get my load function to work because, I don't know why. I couldn't get any numbers into my vector or something. This is why. See the red squiggle? Okay. Load function needs to be able to change the vector. That's why it's not constant. The sort function needs to be able to change the vector. That's why it's not constant. Okay, but anywho, this is everything that we need for our load function. That's it. So let's go ahead and uncomment that and go ahead and run it. If this works, then we're going to get all the correct values out, right? But if you decided that you wanted to write your load function first, well, then you could still test it, right? How would you test it? We'll just print out the contents of the vector, right? So for double D, V, C out, D. Just print out the contents of the vector. Make sure you got the values that you were expecting. Okay. So there's all the numbers. And if I was to open up that numbers dot, let me make sure you can see it. So there's all the numbers. If I had opened up my numbers.txt file, my test text file that I had next to main.cpp, you would see all those numbers in there. So that would be how you could make sure that it works without having to write all the other functions, right? And some of you, I'm sure, are still doing this, right? We're just writing all the functions out, writing the entire program all at once. And then something blows up and you're like, I don't understand what's happening. It's because it kind of defeats the entire purpose of having a modular program. One of the huge benefits of it is that you can, divide and conquer and develop each one of the functions one at a time, and catch bugs early. Okay, so I know my load function works. I know my find highest works. I know my find average works. I know my sort works. I know my print function works. The last thing to do is just integration testing, making sure, one final last test, making sure that everything works together. It should. So you can see that the contents of the vector are now sorted, 1.2, 2.7, and I got to get that stupid Firefox out of the way so you can actually see it. But anyway, so the contents of the vector, 1.2, 2.77, this is all one number, 3.14159, just wrapped on the line here, 6.4, 79583, that's in ascending order. Highest value is 8.3, that is true, and the average value is 4.96027. We know that our average function works based off of our testing earlier, but we could double check this as well, just by adding up all the numbers that we see in the vector and then doing a divide by the size of the vector. So that's it. That is everything. That is the assignment, and that is a solution of the assignment. And it's done in a modular way looking at all of the requirements and following all of the requirements. And every single thing that you needed to do this assignment was covered in chapters 1 through 8. Okay, so hopefully that was helpful to you. Hopefully, by looking at an example of doing the problem in a modular way, in a methodical way, in a systematic way, that any doubts you might have had, or any places where you might got stuck, now you had an aha moment, right? Oh, last thing too, I would make sure that I rename my I would make sure to rename my source code file before I turn it in, right? Otherwise, I'd lose half a point or whatever. And so, in Visual Studio, you can just right click on the file name and then select rename, right? So I'd rename it to, I think the requirement was vectors.cpp or something. And so there you go. Now it's fixed. But yeah, so that's everything. Don't forget that the solution, a solution is posted at the due date for all of the assignments, so you can check those out. And if when I was developing my program, if I was going through my homework and at some point I understand something, or I'm like, what's a constant reference? Well, then I scroll down. Here's an example, or here's an explanation of what a constant reference is and why it's better, including an example prototype. But if I had any questions, if I was confused by one of the requirements, I'd be like, does not interact with the user in any way. What the heck does that mean? Well, it's time to go over to the inbox and send an email, to professor. And I make sure that I get started on this before Sunday night, so that way the professor has a chance to get back to me in time, because it says right here on the landing page and in the syllabus and in the orientation module, expect a response within 48 hours, right? So remember, me as the professor, I'm not an on-call employee, so I check my email often and regularly, but I'm not sitting on my computer 24/7 waiting for you to email me, right? So you got to be reasonable and expect, give me a little bit of time to be able to get back to you, and I will. But yeah, so there you go. There's an example. I hope it helps. If you have any questions about that or anything, just let me know. Okay.